This video will show how to use NCDOT JSLAT to assist in selecting structural BMPs for new development. In a previous video, we demonstrated how to estimate nutrient loads from a fairly complex NCDOT facility using the NCDOT JSLAT model. In that example, we assumed that the site was located in the Upper New Hope subwatershed in the Jordan Lake watershed. In that example, the proposed site plan would achieve the required nitrogen and phosphorus percent reduction requirements for the Upper New Hope subwatershed and would be approved by NCDOT and DENR. However, if this same site had been located in the Falls Lake watershed, it would not meet nutrient goals because neither the annual loading rate targets nor the percent reduction targets would be achieved. In this example, only one target, the percent reduction goal for total nitrogen, is currently being achieved. This video demonstrates options for modifying the site design in order to achieve the Falls Lake watershed nutrient targets on our hypothetical new non-road project site. If the initial post-development plan does not meet the nutrient targets for the watershed, the user could iterate the site design by changing the BMPs on the BMP Characteristics tab to have a greater impact on water quality. It is important to note that JSLAT is a water quality tool and not an engineering design tool. There may be site characteristics such as topography, footprint limitations, seasonal high water table levels, and other site-specific constraints that preclude the use of certain structural BMPs. Changes to the selected BMPs will necessitate changes to the site plan. Therefore, any changes must be approved by the project engineer. In our previous example, a dry detention basin was used in Catchment 1. A bioretention without internal water storage was used in Catchments 2 and 3, and a wet detention basin was used in Catchment 4. The resulting percent reduction for nitrogen, 54%, met the 44% target. However, the percent reduction for phosphorus, 63%, was below the 77% target. To adjust our post-development condition to meet the 77% phosphorus target, we have a few options. First, we could select different BMPs that have a greater capacity to remove phosphorus. Second, we could make other changes on our site plan design that will affect land cover or drainage. Third, we could do a combination of different BMPs in site design. For this example, we are close to meeting our percent reduction targets, so we'll start by selecting different BMPs. The BMP Volume Reductions Effluent Concentrations table on the far right of the Development Summary tab may help the user in selecting another stormwater control. This is a reference table that lists the average runoff volume reduction and effluent nutrient concentrations for various BMPs. When reading this table, BMPs with a lower total nitrogen effluent concentration will typically produce lower nitrogen loading rates than if BMPs with a higher nitrogen effluent concentration were selected. The same is true for total phosphorus. This table also lists the average runoff volume reduction for each BMP type. Note that the volume reduction rates will also affect the final nutrient loading rates for the sites. Other factors, such as site-specific characteristics and cost, may preclude the selection of some BMPs for a given site. The JSLAT user and the project engineer must balance these and other factors when selecting the appropriate BMP for a site. In reviewing the BMP Volume Reductions Effluent Concentrations table, we see that a dry detention basin has a relatively high effluent nitrogen concentration value, and both versions of a bioretention have low effluent nitrogen concentrations. Let's revise one of our BMPs and see how the final nutrient loads for this site change. We'll modify the BMP in Catchment 1 from a dry detention basin to a bioretention basin without IWS. The result of this change shows annual loading rates of 5.19 and 0.89 pounds per acre per year, and percent reductions of 56% and 65%. These are still short of the Falls Lake targets. Let's try again, but this time we'll change the BMP in catchments 2 and 3. On the BMP Characteristics tab, select a dry detention basin for catchment 1 and a bioretention basin with IWS for catchments 2 and 3, and leave catchment 4 as a wet detention basin. On the Development Summary tab, we see that the nitrogen and phosphorus loading rates decrease from 4.44 and 0.61 pounds per acre per year, and that the percent reductions change from 63% for nitrogen and 76% for phosphorus. Comparing these results to our targets in the Falls Lake watershed, we see that the annual loading goals are not achieved, but that the percent reduction goals are achieved. Recall that only one, either the loading goals or the percent goals, needs to be achieved on the site in order to be in compliance with the nutrient strategy. For this reason, this site plan could now be approved by NCDOT and DENR. In this brief example, we did not adjust the size of the BMPs when we changed the BMP type. In reality, the footprint of a BMP will likely change if the BMP type is altered. Changes in the BMP area would then need to be entered in both the Water Characteristics tab and the BMP Characteristics tab. When we have confirmed that the site plan will achieve the nutrient targets for the appropriate watershed, the model can be submitted to the NCDOT hydraulics unit. Model results can be printed through Excel's print dialog or by clicking the Print Summary button. This video showed how to use NCDOT JSLAT to assist in selecting structural BMPs for new development. For additional information related to the NCDOT Green Program, visit the NCDOT Connect site.